Hello students, from the chapters alcohols, phenols and ethers. Last time we have already studied common name and IUPAC name of alcohol. One more system is there for the nomenclature of alcohol. The name of this system is carbinol system. As in this system, alcohols are considered as derivative of methyl alcohol and it is known as carbinol or called as carbinol. See in this example, this group means methyl alcohol is known as carbinol. We are taking more example here. Just see here, CH3OH, it is methyl alcohol and it is your carbinol. Next is ethyl alcohol, means one more carbon atom is there, so you can name as methyl carbinol. Next one is again one more carbon atom is there, means CH3, CH2, CH2OH. So your carbinol is methyl alcohol and remaining two carbon atoms are there. It means it is ethyl carbinol. See in the next example, again one more carbon atom is there, means CH3, CH2, CH2, CH2OH. So your CH3OH is your carbinol and remaining three carbon atom are your propyl group. So the name of the compound is propyl carbinol. Now the next topic from this chapter is preparation of alcohol. From the preparation of alcohol, the first method is from alkyl halide. As you know, the general formula of alkyl halide is Rx. So when alkyl halide undergo alkaline hydrolysis, it gives alcohol. I am repeating here. Alkyl halide undergo alkaline hydrolysis. For example, we are taking alkyl halide having general formula Rx. So Rx, when alkyl halide is undergo hydrolysis, means when it is heating with, it is alkaline hydrolysis. That's why, student, remember, it is alkaline hydrolysis. That's why in alkaline hydrolysis, alkyl halide is heating with dilute aqueous alkali. We are using here NaOH aqueous, dilute aqueous alkali, so it gives its corresponding alcohol. All of you understand this? Alkyl halide undergo alkaline hydrolysis, means alkyl halide heating with dilute aqueous alkali and it gives corresponding alcohol. The example is, we are taking here in place of alkyl halide bromoethane, which is react with sodium hydroxide aqueous, it gives ethanol. Means OH is attached with the alkyl group, it forms ethanol and your byproduct is sodium bromide. Sodium is react with the bromine. Now, next method for the preparation of alcohol is from alkene. This method is known as hydration, means addition of water molecule. Hydration means addition of water molecule. It is the industrial preparation of alcohol. As you know, hydration means addition of water molecule across the double bond in alkene, so we can get easily alcohol. In this method, hydration of alkene is carried out by passing alkene through cold concentrated sulfuric acid. It gives alkyl hydrogen sulfate, which on heating with water give alcohol. I am repeating here. Generally, in hydration of alkene, alkene is passing through cold concentrated sulfuric acid to give alkyl hydrogen sulfate, which on heating with water give alcohol. Now see in the example, as all of you know, alkenes are of two types. One is symmetrical alkene and another is unsymmetrical alkene. When both the alkyl group from both the side of the double bond, the alkyl group are the same, it is known as symmetrical alkene. Both the side of the double bond, if alkyl groups are same, it is known as symmetrical alkene. So, say ethene, we are taking here ethene, it is symmetrical alkene which is react with cold concentrated sulfuric acid. So, see in sulfuric acid, H2SO4. It is in a breaking form, H2SO4. It is your cold concentrated sulfuric acid which is react with ethene. So hydrogen can attach with the one carbon atom and OSO3H group is attached with the another carbon atom. So you can get ethyl hydrogen sulfate. Now this ethyl hydrogen sulfate is heating with water molecule. Again hydrogen is attached with the OSO3H group and your hydroxyl group means OH group is attached with the alkyl group. Fine, means hydrogen is attached with the OSO3H group which will turn into again H2SO4, and your hydroxyl group means OH group is attached with the alkyl group means ethyl group and it form alcohol means ethanol or ethyl alcohol. Clear all of you? It is your symmetrical alkene. Now we are taking here propene. It is unsymmetrical alkene because both the side of double bond alkyl groups are different. Both the side of double bond alkyl groups are different. Again it is react with cold concentrated sulfuric acid. Whole the procedure is same, but remember students, we are using a Markovnikov rule, means negative part of the reagent attached with the carbon atom which carries less number of hydrogen atom. So OSO3H group is attached with a CH group and hydrogen is attached with a CH2 group. Always remember student, you have to take the negative part with the carbon atom carries less number of hydrogen atom. So you can get isopropyl hydrogen sulfate. Now this isopropyl hydrogen sulfate heated with water, same procedure is there. Your hydrogen is attached with OSO3H group and OH is attached with the alkyl group. When the place where you are removing your OSO3H group, you have to attach your OH on that carbon only. So you can get propane 2-ol, means secondary alcohol. So it is hydration of alkene. Now some exceptional cases are there for mono or disubstituted alkene. Means mono and disubstituted alkenes undergo acid catalyzed hydration and it gives alcohol. For example, we are taking here isobutylene which undergo direct hydration, means in presence of 50% H2SO4 it gives tertiary butyl alcohol. We are discussing here mono or disubstituted alkene which direct undergo hydration in presence of 50% H2SO4. See here isobutylene react with water. The procedure is hydration, means addition of water. On the arrow I am writing here H plus. H plus means acid, and as I told you which acid is there, it is 50% H2SO4. So hydrogen atom is attached with carbon atom which carries more number of hydrogen, and your negative part means hydroxyl group means OH minus group is attached with carbon atom which carries less number of hydrogen atom. Again we are using here Markovnikov rule. Your negative part is attached with the carbon atom which carries less number of hydrogen atom, and remaining part is attached with the carbon atom which carries more number of hydrogen atom. So the product is tertiary butyl alcohol. Now again the next method for the preparation of alcohol is from alkene, but in this method we are using hydroboration oxidation. Hydroboration oxidation. Now what do you mean by hydroboration oxidation? So in this method the addition of diborane to the double bond take place in such a way that the boron atom gets attached to less substituted carbon atom, means it follows anti-Markovnikov rule, or it is completely opposite to that of acid catalyzed hydration. Acid catalyzed hydration. Clear all of you? See here in the example, diborane means B2S6. From the diborane, boron atom is attached with the carbon atom which means less substituted carbon atom. Now see here, we are taking a propene. As all of you know, propene is unsymmetrical alkene. The quantity of propene is 6, means carbon in a 6 quantity, hydrogen again 6, means 6 3s are 18, again carbon 6, hydrogen 6, then carbon 6, and here hydrogen 6 means 6 2s are 12. Here boron 2 and hydrogen 6. These 6 hydrogen attached with the CH group. So CH carries 1 carbon and 12 hydrogen. And boron is attached with the CH2 group. But the quantity of boron is 2 and the quantity of whole the propyl group is 6. So you have to arrange this compound that you have your propyl group in a 6 quantity and boron in a 2 quantity. So just see here, I am writing here 2 CH3 CH2 CH2 3. 3 2s are 6 and 2 boron. Student, boron is attached with this carbon atom and hydrogen is attached with the CH group. Total propyl group in a 6 quantity and boron in a 2 quantity. The name of this compound is tripropyl boron. The whole compound tripropyl boron is having a quantity 2. From this 2 quantity, we are taking only 1 tripropyl boron. We are having 2 tripropyl boron, and from this 2 tripropyl boron, we are taking here only 1 tripropyl boron, which is react with hydrogen peroxide. Students, see, in hydrogen peroxide there is 6 hydrogen and 6 oxygen. 6 hydrogen and 6 oxygen. Means tripropyl boron is oxidized to alcohol by hydrogen peroxide. See here on the arrow, I am writing here OH minus, means alkali group is present on the arrow. Normally, dilute sodium hydroxide is used in this reaction. It means that tripropyl boron oxidized to an alcohol by hydrogen peroxide in presence of dilute sodium hydroxide, or you can write here on the arrow OH minus. Now this tripropyl boron propyl group is having a quantity of 3, and from hydrogen peroxide we are taking 3 hydrogen and 3 oxygen, and it is attached with the propyl group. Students, see here, propyl group is having a quantity 3, hydrogen peroxide having 6 hydrogen and 6 oxygen. From these 3 hydrogen and 3 oxygen gets attached with the propyl group, so it will form alcohol. Remaining 3 hydrogen and 3 oxygen attached with the boron group, boron atom, so it will form boron hydroxide. So it is the method of hydroboration oxidation in which we are taking propene in a 6 quantity, react with diboron it will form tripropylborane, which oxidize to an alcohol by hydrogen peroxide in presence of dilute sodium hydroxide. So it will form propane phenol, and your byproduct is boron hydroxide. Now the next method for the preparation of alcohol is from carbonyl compound. The process is reduction. As all of you know, reduction means hydrogenation. Means addition of hydrogen. As you know, student, from carbonyl compound, aldehyde and ketone, both are the carbonyl compound. Means aldehyde and ketone undergoes reduction, means hydrogenation, and it form alcohol. When aldehyde undergo hydration, it form primary alcohol. When ketone undergo reduction, it gives secondary alcohol. From this method, you cannot obtain tertiary alcohol. Means only primary and secondary alcohol can be formed by this method. So just see, reduction of aldehyde and ketone. There are two methods for the reduction of aldehyde and ketone. First is in presence of catalyst, and second is by nascent hydrogen supplied by sodium amalgam and water. Now see, in both the method are same. In presence of catalyst, we are using here hydrogen in a gaseous form, and the reaction carried out in presence of catalyst. By nascent hydrogen, we are taking here hydrogen in a nascent form in presence of sodium amalgam and water. Procedure is same, only reagents are different. Reduction means addition of hydrogen. So just see, I am taking here ethanol, means acetaldehyde. Common name of ethanol is acetaldehyde, which undergo reduction, means hydrogen, addition of hydrogen. Two hydrogens are there. One is attached with oxygen atom and another is attached with carbon atom. So you will get CH3, CH2OH. Ethanol, 1 degree. 1 degree means primary alcohol. I am using here Raney nickel as a catalyst at 413 Kelvin, means temperature is 413 Kelvin. In place of Raney nickel, you can use platinum, palladium, or any one of the catalysts you can use, either Raney nickel or platinum or palladium. Fine. Same here from ketone. I am taking an example propanone. The common name of propanone is acetone. Undergo reduction in presence of Raney nickel. Temperature is 413 Kelvin. Again hydrogen is attached with oxygen atom and one hydrogen is attached with carbon atom. So it gives secondary alcohol, propane 2-ol. 2 degree means secondary alcohol, propane 2-ol. So student, always remember, aldehyde on reduction give primary alcohol, ketone on reduction give secondary alcohol. Next method, as I told you, reduction by nascent hydrogen supplied by sodium amalgam and water. Procedure is same. All the procedure is same. Aldehyde gives primary alcohol, ketone gives secondary alcohol. But only the difference is hydrogen is in a nascent form which is supplied by sodium amalgam and water. So don't get confused in both the reactions. Only the difference is in this method we are using here hydrogen in gaseous form in presence of catalyst and the temperature is 413 Kelvin. And in second method the hydrogen is in a nascent form supplied by sodium amalgam and water. No tertiary alcohol will be obtained by this method. Now the next method is again reduction, but the reduction of carboxylic acid. As you know, the general formula of carboxylic acid are C-double-bond-O-OH. For the preparation of alcohol, normally the primary alcohol is formed here by reduction of carboxylic acid, and a strong reducing agent is required here, for example lithium aluminium hydride. So student, we are doing reduction of carboxylic acid for the preparation of primary alcohol by using a strong reducing agent lithium aluminium hydride. Some conditions are there, as you have seen that lithium aluminium hydride is very expensive. Therefore, first acid is converted into ester, which on catalytic hydrogenation give primary alcohol. Always remember student, first acids are converted into ester, which on catalytic hydrogenation give primary alcohol. See here in general reaction, as all of you know, RCOOH is the general formula of acid. It is react with another alcohol means ROH. The reaction is reversible. Ester is formed RC-double-bond-OR by removal of water molecule. Means H and OH get attached and form water molecule, and what is remaining here RCOOR means ester. These RCOOR undergo catalytic hydrogenation, means addition of hydrogen in presence of catalyst. You can use nickel or palladium, any one of them. Catalytic hydrogenation which form alcohols. Taking an example, I am taking here acetic acid CH3C-double-bond-OH plus CH3OH, means acetic acid or ethanoic acid react with methyl alcohol or methanol, which first converting it into ester, means OH and H both are react together and form water molecule, and remaining compound form product means CH3C-double-bond-O OCH3. It is ester RC-double-bond-OOR means CH3C-double-bond-O OCH3. This ester molecule undergo catalytic hydrogenation and form alcohol. you can divide this stuff from the two part, means CH3C double bond O one part and CH3O is another part. We are taking here 4 hydrogen. From these 4 hydrogen, one hydrogen gets attached with CH3O, so it will form CH3OH, and 3 hydrogen get attached with CH3C double bond O, so it will form ethanol. I am repeating here, from 4 hydrogen, one hydrogen gets attached with CH3O, so it will form methanol, means CH3OH. From the remaining 3 hydrogen, one hydrogen gets attached with O and 2 hydrogen gets attached with C, so it will form CH3CH2OH. CH3CH2OH. So it is ethanol. So this is the method by which we are preparing alcohol, means from carboxylic acid or by reduction of carboxylic acid. I hope students you all are understand this topic. Thank you.